Hi, today we are going to deal with how to integrate in polar coordinate, how to integrate a double integral using polar coordinate, and we have already discussed this. That is double integral over r f of r theta dA is equal to integral from theta ranges and find the r limits and how to find out these limits of integration in this. We have already discussed. Okay, in this we have I think we have done this problem also, right? And also discussed area in polar coordinate equation is given by area equal to double integral over r dr d theta. Find area enclosed by the lemniscate. We have already studied about. For the case of lemniscate, this is the graph of lemniscate. This is we have to study carefully, and this is always the picture of the lemniscate. And for the lemniscate, this start from 0 to pi by 4. Changing the Cartesian into polar coordinates, polar integral. How to change the Cartesian integral into polar integral, that is we are going to deal with. The step 1 is equal to substitute x equal to r cos theta, y equal to r sin theta. Replace dx dy by r dr d theta. Okay, first substitute x equal to r cos theta, y equal to r sin theta. Replace dx dy by r dr d theta in Cartesian integral. Okay, then this integral is equal to double integral f of r cos theta r sin theta into r dr d theta. Next example is equal to find the polar moment of inertia above the origin of a thin plate of density del of xy equal to 1. The density is given, that is equal to 1, bounded by the quarter circle x square plus y square equal to 1 in the first quadrant. We sketch the plate to determine the limits of integration. Limits of integration in Cartesian coordinate, the polar moment value is equal to integral from this is a region, so I have to convert this into, this is integration is 0 to 1, x varies from 0 to 1, so we have to draw a strip corresponding to that. A strip start from this curve to this curve. Here 0, this is root 1 minus x square. This is actually the limits of integration. So integration with respect to y is given by, this is we have to y first to integrate, next we have to do this, convert this, but this is very difficult to integrate. Look this, that is 1 minus x square raised to 3 by 2 by 3. Again we have to integrate this with respect to x. This is very difficult. So in this case we have to convert this into a polar form, and it will be very easy to calculate. So I am converting this to polar form by substituting x equal to r cos theta, y equal to r sin theta, replacing dx dy by r dr d theta. Okay, then this is equal to integral from, then what will be the limits? Theta ranges from, this is in the first quadrant, so we know that it is theta ranges from 0 to pi by 2. Okay, next we have to find out the r value. Here x square plus y square equal to 1, that is r equal to 1. That is r equal to 1. Okay, then r varies from, draw a line from origin through this region. This and start from origin and ends at this point. So r varies from 0 to 1. And what will be this one? This is equal to r square. D by dx is converted into r dr d theta. And total is r cube dr d theta. R cube derivative integration is r raised to 4 by 4 varies from 0 to 1, that is 1 by 4 into integral 0 to pi by 2 d theta, that's equal to pi by 8. Okay. So in this case, look, why the polar coordinate transformation is effective. The reason is that it simplifies this x square plus y square into r square. Okay, and when we are converting this coordinate into the rectangular coordinate into polar coordinate into Cartesian coordinate into polar coordinate, then the limits of integration become the constant, and we can without any disturbance we can evaluate this, right? Similarly, we can do this one. Double integral over r e raised to x square plus y square into dy dx. R is a semicircular region bounded by, this is the left side, this is the region in this. Look through the solution. Here there is no direct way to integrate e raised to x square plus y square with respect to either x or y. Okay, in order to do this, I'm converting this x is equal to r cos theta, y equal to r sin theta, and replace dy dx by r dr d theta. So this is equal to e raised to r square into dy dx is converted into r dr d theta. Then how will you convert this? How will you find out the limits? And we know that this is in the first and second quadrant. This covers the first and second quadrant. So theta varies from 0 to pi. And how to find out this? R varies from, draw a line from origin through this region, and this is actually 0, and this end determines by r equal to 1. Put x equal to r cos theta, y equal to r sin theta here, then you can solve this and we can see that r equal to 1. So r varies from 0 to 1, e raised to r square into r dr d theta. So put r square is equal to some t, then we will get 2r dr is equal to some dt, and we can, by substitution method, we can solve this. The answer will be pi by 2 into e minus 1. Okay, this is you have to do carefully, and you have to do at least 5 times you have to do by taking a new paper and write the question and do the problem without looking to any other textbook or notebook. You have to do yourself, and at least 5 times you have to do this carefully, then only you can remember this. Okay, and also you do this problem exercises also. These exercises. Okay, in the next video we will discuss about the triple integral. Okay, in the case of the double integral, we get the main contents in this double integration is double integral the Cartesian coordinate. In the case of the Cartesian coordinate system, how to evaluate the double integration, how to find out the limits of integration, find the area. Next is double integral in polar form and the area in polar form. How to convert this? Next is the third portion is changing from Cartesian coordinate to polar coordinate by substituting x equal to r cos theta, y equal to r sin theta. Okay, this we have discussed in this class. So you do all the problem in the exercises and please ask me if any doubt comes. Okay, thank you.